Good morning to all of you. Today we will study engineering thermodynamics. Last class I have done 130 number of problems, 113 problems. This is problem number 114. This problem relates to this problem relates to general gas law equations. Now the question is an ideal cycle consists of three processes. Used argon gas having molecular mass 40 as working fluid. We already discussed, we already done problems using air as working fluid, but in this problem, we'll use argon as working fluid. The argon having molecular mass 40. Clear? The process 1 2 is reversible adiabatic expansion from 0.014 meter cube, 700 kilopascal, and 28 degree centigrade to 0.056 meter cube. Process 2-3 reverse isothermal. Process 3-1 is constant pressure process in which heat transfer is 0. Find the net work done for the process, for the cycle. Take gamma 1.67. This organic gas, so its gamma is different. In air we use gamma, we take gamma as 1.4. But this organic gas is a molecular mass of 40, and gamma is 1.64. Clear? Now first draw the PV diagram. Right? This is pressure, volume. Pressure P. This is pressure P, volume B. Clear? The process 1-2 is adiabatic expansion. This is process 1-2. 1-2 adiabatic expansion. Process 2-3. Process 2-3 is reversal isothermal. This is reversal isothermal. Process 3-1. This is 2-3. This is 3-1 constant pressure. 1-2, 2-3, 3-1. Clear? This is P to gamma constant. This is PPU constant. This is equal to pressure constant. Only P is your constant. In this process, this is P1 is your P3. Clear? This is B1, B2, B3. Origin. Now, first write the given data. An ideal cycle consists of three processes using argon as working fluid. Argon. Having molecular mass 40. Clear? Argon. What is the molecular mass is equal to? 40. Gamma 1.67. 1.67. Now, P1 700 kilopascal, pressure P1 is equal to 700 kilopascal, B1 is equal to 0.014 meter cube, 0.014 meter cube. Clear? T1 is equal to 280 centigrade. T1 is equal to 280 plus 273, 553 Kelvin. T1. Right? Next, B2 is equal to 0.056 meter cube. And Q31 is equal to 0. Clear? Find net work transfer. Double net means double net. What is double net? Net work transfer. Now we will find out double 1 2, double T3, double 3 1. So double is equal to double 1 2 or double 2 3 or double 3 1. Now count to process 1 2. Process 1 2. Process 1 2. Process 1 2. T2 by T1 is equal to B1 B2 power of B1 by B2 power of gamma minus 1. So T2 is equal to T1 into B1 B2 power of gamma minus 1. Clear? What T1? T1 553. This is equal to 553 into B1 by B2 0.014, B2 0.056, 056 to the power of gamma minus 1, 1.67 minus 1. This is T2. Clear? T2 is equal to 218.446. 218.446 Kelvin. You use calculator, solve this answer. T2 is equal to 218.446 Kelvin. Now we'll find out P2. So T2 is equal to 218.446 Kelvin. So P2. What is P2? P1 B1 per n gamma is equal to P2 B2 per gamma. Clear? So P1 B1 gamma is equal to P2 B2 per gamma. So what is P2 is equal to P1 into B1 B2 power of gamma. What is P1? 700. B1 by B2. What is B1? 0.014 by 0.056 to the power of gamma, 1.67. So find out P2. What is P2? P2 is equal to 69.123 kilopascal. Right? This is P2. P2 is equal to 69.123 kilopascal. Now we have T2, B2, T2. Now what done? So process 1 2 is a adiabatic expansion process. So what is what done is equal to P1 B1 minus P2 B2 by gamma minus 1. Clear? So what done is equal to double 1 2 P1 B1 minus P2 B2 by gamma minus 1. We have below P1 P2 P2 and also gamma. So put all the values, we'll find out what done. Process 1 2 double 1 2 will find out. What is P1? 700. So double 1 2 is equal to 700 into what is B1? 0.014 minus P2. What is P2? 69.123. B2 0.056 by Clear? Gamma means 1. What is gamma? 1.67 minus 1. So double 1 2 is equal to 8.84 kilojoule. 8.84 kilojoule. This is what done during process 1 2. Clear? Now double 1 2 is equal to 8.84 kilojoule. Now come to process 2 3. 2 3 is equal to isothermal process, reversible isothermal process. Process 2 3. This is reverse isothermal process. So what is what done is equal to double 2 3 is equal to P2 V2 ln V3 by V2. Clear? V3 by V2 means P2 by P2. Now the process 2 3, T2 is equal to T3. This is isothermal process. So T2 is equal to T3. So P2 V2 by T2 is equal to T3 V3 by T3. T2 T3 cancel out. Clear? Now this implies so P2 V2 is equal to P3 V3. This implies P2 by P3 is equal to V3 by P2. So put this value of P2 by P3 in the place of V3 by V2. Now W23 is equal to, so W23 is equal to P2 V2 ln P2 by P3. Clear? So W23 is equal to P2 V2. What is P2? P2 69.123 69.123 into V2 0.056 ln P2 by P3. What is P2? 69.123 by P3. P3 means P1. What is P1? P1 is equal to 700 kilopascal. P1 is equal to 700 kilopascal. P3 means P1. Clear? Use calculator. The answer will be W23 is equal to minus 8.96 kilojoule. Minus 8.96 kilojoule. Right? Here double 1 to 8.84 kilojoule. We have W23 minus 8.96 kilojoule. We'll find out W31. Clear? Now process 31. So W31 is equal to P1 into or P3 into V3 minus V1. This is compression process. So this is P1 into V1 minus V3. Okay, or you may write V3 V1 compression negative. So P1 into V3 minus V1. Since this is a compression process, 5 elements initial. Clear? 5 elements B1 minus B3. So this compressor process, so we will use B3 minus B1. So what is W31 is equal to P1 into, right, B3 minus B1. This compressor process. So the answer will be negative, or you use this equation P1 into 5 elements initial. 5 elements B1 minus B3. Clear? So what is P1? 700 into B1 minus B3. What is B1? What is B1? B1 is equal to 0.014. 0.014 minus B3. What is B3? We find out B3. Now we find out to B3. In process 1 3, and B3. Now in process 2 3, P2 B2 is equal to P3 B3. Process 2 3. We find out B3. So what is B3 is equal to P2 B2 by P3. P3 means P1. So P2 B2, what is P2? 69.123 into B2 0.056 by P1 700. This is B3. Right. Now B3 is equal to 0.00553 meter cube. So this is B3 0.00553 meter cube. Clear? Now what done? What done is equal to P1 into B1 and B3. So this is what done. 331 is equal to, this answer is 331 5.98 kilojoule. 5.98 kilojoule. This is 112, 223, 331. So net work transfer. Or you check the answer. Clear? Use calculator. You will find the correct answer. Answer this. I am not using calculator. Use calculator. Clear? Now net work transfer. Net work transfer. Double net is equal to 112 plus 323 plus 31. Clear? So you put all the values and find the answer. Double net is equal to something kilojoule. The answer is in kilojoule. Clear? Since 112 is kilojoule, 223 kilojoule, 31 is also kilojoule, so the net work transfer is also in kilojoule. Clear? Next question I will do 115. These questions are very important. So when you solve the answer, use calculator and make silence to solve the question. This question consists three processes: additive process, constant temperature process, and constant pressure process. Clear? Similarly, if he is asking find net heat transfer, in this case also you can find out Q12, Q23, Q31, then net heat transfer Q is equal to or Q net is equal to Q12 plus Q23 plus Q31. Clear? Next question 115. Now, this is question number 115. The question, very important question. The question is, a gas occupies 0.024 metric at 700 kilopascal and 95 degree centigrade. It is expanded in the non-flow process according to the law PV to 1.2 constant to a pressure of 70 kilopascal, after which it is heated at a constant pressure back to its original temperature. Find for the process 1, 2 and 2, 3. Whole process means process 1, 2 plus process 2, 3. The total work done, the heat transferred, and total change in entropy. Take Cp is equal to 1.047 kJ per kg Kelvin and Cb is equal to 0.775 kJ per kg Kelvin. Clear? Now first draw the PV diagram. This is pressure, the volume V, pressure P. Clear? Now, according to the law, PV to 1.2 constant expansive process. The expansive process 1, 2, then constant pressure process 2, 3. Clear? 1, 2, 3. Process 1, 2, constant pressure. Process 2, 3. Process 1, 2, PV constant. Polytropic. Process 2, 3, constant pressure. This is PV to N constant. This is pressure is constant. Now, write the given data. A gas having volume 0.024 metric cube means V1. What V1 is equal to? 0.024 metric cube at 700 kilopascal. P1 is equal to 70 kilopascal and temperature T1 is equal to 95 degree centigrade. T1. So 95 plus 273 is equal to 363 Kelvin. Clear? According to the law, PV to 1.2 constant means polytropic. PV to the power of 1.2 constant means N is equal to 1.2 to 70 kilopascal P2. P2 is equal to 70 kilopascal and then back to initial temperature means T3 is equal to T2 is equal to T1, not T2. T1 is equal to 360 Kelvin. Clear? 1, 2, polytropic process, 2, 3, constant pressure of heating. After this, the process reaches to its initial condition, initial temperature means T1. So T3 is equal to T1, 360 Kelvin. Clear? Take Cp is equal to 1.047. Cp is equal to 1.047 kilojoule per kg Kelvin. And Cb is equal to 0.778 kilojoule per kg Kelvin. Right? Now, process 1 2. Process 1 2. PBN constant. PBN constant. We have P1, B1, T1, P2. Not B2, not T2. Now, P1, B1 is equal to P2, B2 per N. So, P1 by P2 is equal to B2 by B1 per of N. Clear? So, B2 by B1 is equal to P1 by P2 per of 1 by N. What is B2 is equal to? B1 into P1 by P2 per of 1 by N. This is B2. Clear? So B2 is equal to, find out B2 0.1635 meter cube, 1365 meter cube. This is B2. And we will find out T2. This is B2. We have T1. And find T2. Now T2 at T1 is equal to P2 at P1 to the power of n minus 1 by n. So T2 is equal to P1 into P2 at P1 to the power of n minus 1 by n. So T2 is equal to T1. What is T1? 368 into P2 at P1, 70 by 700 to the power of n minus 1 by n. 1.2 minus 1 by 120. We find out T2. Here, now T2 is equal to 250.715 Kelvin. 250.75 Kelvin. T2. Next, B2 is equal to 0.1365 meter cube and T2 is equal to 250.715 meter cube. Now, Now R, what is R is equal to Cp minus Cv, 1.047 minus Cp means 0.778. So R, clear? What R is equal to 0.272, 0.272 kilos to the power kg. This is R. Now gamma 1.4, gamma not 1.4, Cp by Cb. Cp means 1.047 by 0.778. So gamma is equal to 1.35. Clear? R 0.272, gamma 1.35. Now mass M. What is P1? V1 is equal to MR T1. P1 V1 MR T1. So what is M is equal to P1 V1 by R T1. P1 means 700. P1 means 0.024. R means 0.272. T1 368. Find out M. What M is equal to? M is equal to 0.16783. 0.16783 kg. Now all values we find out. Now put the formula for work done. This is process 1, 2. So for process 1, 2, work done double 1, 2 is equal to P1 V1 minus P2 V2 by and minus 1. Clear? What is P1 V1? P1 we have P1 V1 P2 V2. What is P1? 700. So double 1, 2 is equal to 700 into V1 means 0.024 minus P2 means 70. Clear? V2 is equal to 0.1365 by n minus 1, 1.2 minus 1. Clear? Use calculator find value 26.72. So double 1, 2 is equal to 26.72 kilojoule. What done during process 1, 2. Then heat transfer during 1, 2. Heat transfer. Heat transferred Q1 2 is equal to gamma and gamma 1 into double 1, 2. Clear? What is gamma? 1.35 minus 1.2, 1.35 minus 1. What done? What is what done? 26.72. Clear? Q1 2. Now Q1 2 is equal to 470 kilojoule. 11.470 kilojoule. This is heat transfer. What done? Next, change in entropy. Now, change in entropy. Delta is 1 2. Delta is 1 2. Clear? Delta is 1 2 is equal to gamma is n by gamma is 1 into mr ln v2 by v1. mr ln v2 by v1. Clear? Put all the values. So delta is 1 2 is equal to gamma 1.35 minus 1.2 by 1.35 minus 1 mr. What m is equal to? M is equal to 0.16783 ln V2 0.1365 by V1 0.024. Clear? Put the value, find delta is 1 2. Now delta is 1 2 is equal to 0.901 kilojoule per kg Kelvin per kg kilojoule per Kelvin. This is mass, solely kilojoule per Kelvin. Next, come to process 2 3. These are the values W12, Q12, delta is 1 2 for process 1 2. Now come to process 2 3. Process 2 3 means constant pressure process. Constant pressure process. 2 3 constant pressure process. Now P2 is equal to P3. Clear? So P2 by T2 is equal to P3 by T3. Given T3 to T1 and P2 is equal to P3. Clear? Now find value of V3. This is V3. This implies V3 is equal to T1 into V2 by T2. So V3 T1. What T1? 368 into V2 0.1365 by T2. T2 is equal to T2 is equal to 250.715. 250. Clear? Use calculator. Find the value V3. V3 is equal to 0.239. 0.2398 metric cube. Now all values of P2, P3, T3, V2, V3, V3, V2, V3, P2, P3, T3, B2, P2, T2, and P1, V1, T1 all are find out. Now we find below what done heat transfer change in entropy for the process 2 3. Clear? Now what done? What done? Double 2 3 is equal to P2 into V3 minus V2. P2 into V3 minus V2. So what is P2? P2 70 into V3 as V2. V3 0.23998 minus V2 means 0.1365. 0.1365. So this is double 2 3. Clear? So double 2 3 is equal to 5.355 kilojoule. 5.355 kilojoule. This is double 2 3. Q23. Now heat transfer Q23. Q23 is equal to MCP T3 minus T2. So Q23 is equal to M, or M is equal to M is equal to what is M is equal to 0.168 CP 1.047 T3 minus T2. T3 means 368 minus T2 250 cents and 250.75. This is Q23. Right? So Q23 is equal to Q23 20.629 kilojoule. Right? Now double 2 3 Q23. Next change in entropy delta 2 3. Now change in entropy deltas 2 3. Deltas 2 3. Delta 2 3 is equal to MCP ln T3 by T2. T3 by T2. What is M is equal to? Delta 2 3 is equal to M 0.168. CP means 1.047 ln T3 by T2. T3 means 368. T2 means 250.715. This is delta 2 3. Right? So delta 2 3 is equal to 0.675 kilojoule per Kelvin. Clear? Now the question consider two processes, process 1 to process 2 3. Now we find out the total work done, total heat transfer and total change in entropy for 1 2 and 2 3. Clear? Now total work done is equal to W is equal to W12 plus W23. So work done is equal to W12 26.7, W23 5.355. Both are kilojoule. So the answer is also kilojoule. Clear? So W is equal to 32.525 kilojoule. Both are kilojoule, so the answer is also in kilojoule. Next, total heat transfer. Total heat transfer. Q is equal to Q12 plus Q23. For Q12, this is Q12, 11.472, 11.472 plus Q23, 20.629. This is Q. Clear? So Q is equal to 30.102, 30.102 joule. Right? We'll find out total change in entropy, deltas. Total change entropy del S. So del S is equal to del S12, del S23. So del S is delta S12 कितना 0.909, 0.901 plus 0.615. Clear? This is 9694. Now this is total heat transfer, total work done, total change in entropy. Clear? This is question number 115. This is question number 116. The question is a closed rigid cylinder container is divided into two diaphragms. One, two. Each having two equal compartments, each of volume 0.1 meter cube and contains a rate 20 degrees centigrade. The pressure in one is 2.5 megapascal and the other is 1 megapascal. Now the diaphragm ruptured so that both the compartments mixes to bring the pressure to uniform state. Find net change in entropy for the mixing process. Clear? So This is container 1, this is container 2, this partition. Now the partition is removed, both mixed to a common pressure. Clear? So this 1 plus 2. 1, 2, this is 1 plus 2. Clear? Now come to question. The diaphragm between 1 and 2. So when this is removed, diaphragm removed, both are mixed together. So both becomes 1 plus 2. Clear? Now, a closed container is divided two parts, each volume pound diameter cube. That means B1 is equal to B2 is equal to pound diameter cube. Having temperature equal, T1 is equal to T2 is equal to 20 remains 20 plus 273. So T1 is equal to T2 is equal to 293 Kelvin. Clear? Now the pressure in one is 2.5 megapascal and other is 1 megapascal. Clear? So P1 is equal to 2.5 megapascal 2500 kilopascal and P2 is equal to 1 megapascal means 1000 kilopascal. Right? Now both are now the diaphragm is removed and both mixed together to brought a uniform pressure P. Clear? So after mixing, we'll find out all values. First find out M1 and M2. Now this air, what is P1? P1 is equal to M1 at T1. So what is M1 is equal to P1 by R T1. P1 means 2500. B1 is equal to 0.1 by R 0.27 into T1 293 mass M1. Right? So find M1 is equal to 2.932 kg. 1. M2. What P2 V2 is equal to M2 RT2. What is M2 is equal to P2 V2 by RT2. Clear? So M2 is equal to P2 V2. P2 means 1000 into V2 means 0.1 by RT2. What is R? 0.27 into T2 means T2 293 M2. Right? M2 is equal to 1.19 kg. This is 1 and 2. Now both are mixed together. The diaphragm is removed So both come to uniform pressure and also the temperature is also equal because T1 is equal to T2 is also equal to T. And after mixing, now after mixing, P is equal to Q1 is equal to T2 is equal to 293 Kelvin. Clear? T. M is equal to M1 plus M2. What is M1? 2.932 plus 1.19. M is equal to, right? What M is equal to? M is equal to 2.932, 4.13 kg, 4.13 kg. M is equal to. Clear? Now, volume V. So after mixing, volume V is equal to V1 plus V2. What is V1? 0.1. V2 also 0.1. So V is equal to 0.2 meter cube. V1, V2. Now come to equation of state or characteristic gas equation. Now P is equal to common pressure after mixing. After mixing. Now what PB is equal to? MRT. So P is equal to MRT B. MRT by B. What M is equal to? 4.13 R 0.287. T is equal to T 293 by B 0.214. B is equal to 0.214. 0.2, not 14. Clear? So P is what the answer of P. P is equal to 1749. P is equal to 1749.933 kilopascal. This is P. P, B, T, M. All are found out. Now, total change in entropy. Total change of entropy deltas. Deltas is equal to deltas 1 to deltas 2. Deltas 1 to deltas 2. Clear? So del S is equal to deltas 1 MR ln Q1 by P plus MR ln P2 by P. Right? This is deltas. Now delta is mr. What is m? 4.13 into r. 0.287 into ln p1 by p1. What is p1? p1 is equal to 2500 kilopascal. P, what is p? P is equal to 1749.933 plus mr ln p to ap. It means 413 ln 0.27 into p to ap ln p2. P2 means what is p2? 1000 by P1749.933. Clear? So delta total is equal to 0.113113. Clear? This completes the problem 116. Next class I will do 117. Thank you. Make all our channels like, share, subscribe and watch the full video. Thank you.